Hey everyone, and welcome to this explainer. Today, we're going to take something that honestly seems incredibly dense and industrial. I mean, we're talking complex plumbing and water filtration here, and we're going to transform it into a microscopic adventure. We are going to find out exactly how reverse osmosis works to purify your tap water, basically turning an ordinary, everyday drop of water into a pristine resource. To pull this off, we're going to follow a single drop of water through our 5 agenda items for today. Demystifying reverse osmosis, Stage 1, pre-treatment shield. Stage 2, the mighty membrane. Stage 3, polish and store. And finally, the limits of RO. Let's see exactly how this water drop navigates a microscopic obstacle course from the second it enters the pipes to the moment it hits your glass. All right, Section 1, demystifying reverse osmosis. What exactly is RO? Let's dive right in by establishing what we mean when we use this somewhat intimidating term. So, stripped of all the dense plumbing jargon, the core idea here is actually incredibly straightforward. Reverse osmosis, or RO for short, is really just about applying pressure to push water through a highly exclusive barrier. Imagine a VIP club where the bouncer is so strict, literally only the absolute purest guests are allowed inside. That's essentially what we're doing. We take raw tap water, which, let's face it, might be carrying a whole host of uninvited guests, like dissolved salts, heavy metals, and various contaminants, and we forcefully separate the good from the bad. Now, to achieve that remarkable level of purity, most home and commercial RO systems are built on this exact 3-step blueprint. It's a continuous forward journey for your water: pre-treatment, the RO membrane itself, and finally, post-treatment. I want you to think of these not just as a bunch of pipes, but as 3 distinct lines of defense, each playing an absolutely crucial role in the ultimate goal of clean drinking water. Moving on to Section 2, Stage 1, the pre-treatment shield. Before our little drop of water gets anywhere near the main filter, it has to survive this first major hurdle. You know, what's really fascinating here is understanding why this pre-treatment even exists. You might think the main filter just does all the heavy lifting, right? Well, actually, raw water comes loaded with physical hazards. So our water drop is first pushed through a sediment filter to physically strip away abrasive particles like sand, rust, and fine debris. Then it typically hits an activated carbon filter to remove chlorine. And here's the really interesting part. Removing that chlorine isn't just about making your water taste better right off the bat. It's because chlorine is highly destructive. These specific chemical and physical threats can actually foul or permanently ruin the delicate, super expensive internal membrane over time. So the pre-treatment shield is literally there to take a bullet for the main filter. Section 3, Stage 2, the mighty membrane. Having survived the pre-treatment gauntlet, we now move to the heart of the system, where the water faces its toughest challenge yet. This is the RO membrane. It is a highly engineered, shockingly thin, semi-permeable barrier. Under high pressure, and I can't stress enough, that pressure is absolutely key here. The water is shoved relentlessly against this barrier. Remember that VIP bouncer analogy we talked about earlier? Well, this microscopic bouncer strictly only lets H2O pass. The pores in this membrane are so unimaginably small that the dissolved heavy metals, the lingering salts, and all those stubborn contaminants are simply, physically, just too large to squeeze through. And at this exact moment, we see the dramatic divergence of our water drop. Right at this membrane, the path splits into 2 totally different streams. On one side, we have our hero, the permeate. This is the purified, pristine water that successfully fought its way through the membrane. On the other side, we have the concentrate, basically the villain of our story. This is the water holding all those rejected, clustered contaminants that couldn't pass the barrier. This concentrate stream is flushed away, directed straight down a drain or diverted to a reuse pathway, completely banished from your drinking supply. No way it's getting in. Section 4, Stage 3, polish and store. Our victorious purified permeate has made it through the mighty membrane, but its journey actually requires one final touch before it reaches your glass. This brings us to the post-treatment enhancements. Listen, because reverse osmosis is so incredibly aggressive at stripping things out of the water, it sometimes takes away the things we actually want, or it leaves the water tasting, just a bit flat. Depending on the specific system, the water might get a final trip through another carbon filter, which acts as a polish to ensure a super crisp taste. Alternatively, some systems feature a remineralization stage. This intentionally adds beneficial minerals back into the water based on the starting chemistry. Pretty cool, right?
Finally, because forcing water through that microscopic membrane is such a slow, laborious process, the clean water usually waits in a pressurized storage tank so it's ready on demand when you open the faucet. Or if you're looking at newer tech, modern high-efficiency tankless designs can actually push water through right exactly when you need it.
Okay, Section 5, the limits of RO. As incredibly effective as this microscopic obstacle course is, it's vital to ground ourselves in reality here. Reverse osmosis is physics, not magic. So the absolutely crucial point to remember is this. While RO is a powerhouse against dissolved solids and salts, it's not an invincible catch-all for every single threat out there. No single filtration method is. Certain volatile organic chemicals or dissolved gases can actually slip right through that membrane alongside the H2O. If your specific source water has those exact issues, the RO membrane alone simply won't save you. You'd require highly specialized pretreatment steps explicitly designed to target those specific gases.
Ultimately, the success of this entire journey relies heavily on you. Maximizing your RO performance definitely isn't a set it and forget it kind of deal. It depends heavily on operating pressure. If your home's water pressure drops, the system just fails to push the water through effectively. And most importantly, it requires following manufacturer guidance for filter replacements. Remember that pretreatment shield we talked about? If you don't swap out those sediment and carbon filters on schedule, chlorine and rust are going to tear right through and destroy your main membrane. It really necessitates periodic water testing on your part to genuinely confirm the system is still performing exactly as intended.
So now that you deeply understand the mechanics, the heroic journey of the permeate, and the very real limits of this fascinating process, I want you to take a look at your own tap. Ask yourself, knowing the specific contaminants this technology targets and the strict maintenance it demands from you, does your home truly need this level of microscopic filtration? Or is a simpler filter actually enough for your local water chemistry? It is absolutely a question worth investigating. Thank you so much for joining me on this explainer today. Keep asking questions, and I'll catch you on the next one.